Long before cities, electricity, computers, or artificial intelligence, humanity faced a fundamental problem. Every discovery existed only inside someone's mind. A skilled hunter could learn the migration patterns of animals. A healer could discover which plants cured disease. A builder could understand how to construct a stronger shelter. But when that person died, much of that knowledge disappeared forever. Civilization was trapped in a cycle of constantly rediscovering what previous generations had already learned. Human intelligence existed, but it had no permanent memory. The greatest limitation wasn't a lack of ideas, it was the inability to preserve them. Everything changed when humans began recording ideas using symbols. Whether carved into stone, impressed into clay, or written onto papyrus, these marks represented one of the greatest technological breakthroughs in history. Writing allowed information to exist outside the human brain for the first time. Knowledge could now survive its creator and travel across generations. Every law, engineering drawing, mathematical formula, and scientific observation became part of a growing archive of human understanding. Civilization had invented something remarkable, an external memory system that no longer depended on human recall. Once ideas could be preserved, they could also accumulate. Instead of starting from the beginning, each generation built upon the discoveries of the last. Mathematics became more sophisticated, navigation improved, architecture advanced, engineering evolved from simple structures into increasingly complex machines. Knowledge was no longer isolated, it became interconnected, with every new discovery reinforcing countless others. This compounding effect transformed human progress from a slow, repetitive cycle into an accelerating journey of innovation. The true power of writing wasn't simply communication, it was the ability to make knowledge grow continuously. For centuries, books were copied by hand, making knowledge scarce and expensive. Then, one invention transformed civilization again. The printing press allowed information to be reproduced thousands of times with remarkable accuracy. Ideas that once remained confined to monasteries, scholars, or kings could now spread across entire continents. Science, engineering, medicine, and education advanced at unprecedented speed because millions of people could learn from the same discoveries simultaneously. Human intelligence had become scalable. Knowledge was no longer limited by geography. It had become a global resource capable of accelerating civilization itself. As knowledge expanded, humanity began asking deeper questions about how the universe truly worked. Observation evolved into experimentation. Curiosity became scientific method. Mathematics unlocked the laws of motion. Chemistry revealed the building blocks of matter, and engineering transformed theory into practical machines. Science wasn't simply another collection of facts. It became a systematic process for discovering entirely new knowledge. Humanity was no longer just recording the world. It was learning how to understand it, predict it, and eventually reshape it. Every technological revolution that followed would emerge from this scientific foundation. Even with growing knowledge, civilization faced another fundamental limitation: energy. Every building, every farm, every road, and every tool depended on human or animal muscle. Windmills and water wheels helped, but their power was limited by nature. Population growth demanded more food, larger cities, and greater productivity than muscle alone could provide. Humanity had learned how to think more effectively, but it still lacked the energy required to transform those ideas into large-scale civilization. Intelligence was advancing rapidly. Energy was becoming the new bottleneck. Coal became the first great energy breakthrough that fundamentally reshaped human civilization. Steam engines converted stored chemical energy into continuous mechanical power, allowing factories to operate day and night, locomotives to cross continents, and industries to expand beyond anything muscle could ever achieve. For the first time, machines began performing work on a massive scale. Productivity exploded, cities grew rapidly, and the Industrial Revolution transformed economies around the world. Human knowledge had created powerful machines, but it was abundant energy that finally allowed civilization to unlock their full potential. Coal powered the Industrial Revolution, but another energy source would make civilization truly global. Oil contained an extraordinary amount of energy in a liquid form that could be transported almost anywhere. It powered automobiles, aircraft, ships, construction equipment, and eventually the entire global supply chain. Suddenly, goods could move across continents. People could travel farther than ever before, and industries became interconnected on a worldwide scale. Nearly every modern convenience, from food distribution to international trade, was built on this hidden network of petroleum. Human civilization had become mobile because it had discovered a more flexible source of energy. If coal gave civilization power and oil gave it mobility, electricity gave it connectivity. Unlike any previous energy source, electricity could be generated in one location and delivered almost instantly to millions of people through an interconnected grid. Homes, factories, hospitals, communication systems, transportation networks, and entire cities all became part of one enormous electrical machine. Every switch, every motor, every computer, and every light depended on the invisible flow of electrons traveling through transmission lines and substations. Modern civilization no longer depended on individual machines. It depended on a vast electrical network quietly operating every second of every day. Looking back across history, a remarkable pattern begins to emerge. Every major breakthrough in human knowledge has required an even greater breakthrough in energy. Writing enabled civilization. Science accelerated discovery. Industry demanded coal. Global transportation demanded oil. Electrification connected the modern world. Intelligence and energy have evolved together for thousands of years, each enabling the next stage of human progress. But this timeline also raises an important question. If every technological revolution required more energy than the last, what kind of energy system will be needed to support the next revolution already unfolding? The invention of the computer marked another turning point in human history. For the first time, machines could process information instead of simply performing physical work. Calculations that once required weeks could now be completed in seconds. Engineers designed more complex systems, scientists analyzed enormous datasets, financial markets accelerated, and digital communication transformed business around the world. Computers didn't replace human intelligence, they amplified it. Just as steam engines multiplied physical labor, computers multiplied mental capability. Computers became even more powerful once they were connected together. The internet transformed billions of individual machines into one global information network, allowing knowledge to move across continents almost instantly. Universities, businesses, governments, researchers, and individuals could now collaborate regardless of geography. Humanity had effectively built a digital nervous system, connecting nearly every corner of the planet. Information became one of civilization's most valuable resources. Artificial intelligence represents something fundamentally different. Instead of simply storing information, AI can recognize patterns, generate ideas, assist scientific research, design engineering systems, and solve increasingly complex problems. It has become another layer of intelligence built upon everything humanity has previously learned. Yet behind every AI conversation lies an enormous physical infrastructure that most people never see. Every time someone asks AI a question, an extraordinary engineering system comes to life. The request travels through fiber optic networks into massive data centers containing thousands of advanced processors. Those processors perform trillions of calculations, while sophisticated cooling systems remove enormous amounts of heat. Every response depends entirely on electricity flowing continuously through servers, transformers, substations, and transmission lines. AI may appear digital, but it is powered by physical infrastructure. Artificial intelligence is only one part of a much larger picture. Hospitals, water treatment plants, factories, transportation systems, communication networks, financial markets, and cloud computing all depend on one invisible foundation: electricity. The electrical grid has become the operating system of modern civilization. If electricity stops flowing, nearly every critical service stops with it. Today's electricity demand is growing faster than ever before. Artificial intelligence, electric vehicles, robotics, electrified heating, automated manufacturing, and digital infrastructure are all expanding simultaneously. Humanity is not adding one new industry. We are electrifying almost everything. The result is the largest increase in electricity demand in modern history. Behind every intelligent system stands an even larger energy system. Modern AI data centers require dedicated substations, high-voltage transmission lines, cooling plants, backup power systems, and enormous computing clusters operating around the clock. Intelligence has become an infrastructure challenge as much as a software challenge. No single technology can satisfy future demand. Tomorrow's energy system will combine solar, wind, hydroelectricity, nuclear power, batteries, transmission networks, hydrogen, and advanced storage into one coordinated ecosystem. The challenge is no longer generating electricity alone. It is managing an increasingly complex system capable of delivering reliable energy everywhere it is needed. Some industries remain difficult to electrify directly. Steel manufacturing, aviation, shipping, chemicals, and long-duration energy storage require additional solutions. Hydrogen becomes an important part of this future infrastructure because it stores energy, transports energy, and supplies industries that electricity alone cannot easily serve. Rather than replacing electricity, hydrogen extends its capabilities. As energy systems become more complex, artificial intelligence becomes their coordinator. AI can forecast renewable generation, balance electricity demand, optimize battery storage, schedule hydrogen production, and improve grid reliability in real time. Intelligence is no longer just consuming electricity, it is beginning to manage it. Human civilization is entering a new era where intelligence and energy evolve together more closely than ever before. AI accelerates science, engineering, medicine, manufacturing, and transportation. But every breakthrough depends upon abundant, reliable, and increasingly clean energy. The next civilization will be powered by both intelligence and infrastructure. Throughout history, humanity has built two invisible systems. One preserves knowledge, the other delivers energy. Writing, science, computers, and AI belong to one system. Fire, coal, oil, electricity, hydrogen, and advanced grids belong to the other. Civilization advances only when both systems grow together. The next generation of discoveries, from robotics and biotechnology to advanced manufacturing and space exploration, will require more than brilliant ideas. They will require unprecedented amounts of clean, reliable energy. Human imagination is expanding rapidly, but the future depends on whether our energy systems can expand just as quickly. From space, civilization appears as a network of light stretching across continents. Every illuminated city, every factory, every hospital, every communication network, and every AI data center represents energy transformed into human progress. The energy transition is not simply about replacing fuels, it is about building the foundation for the next century of civilization. Looking back across history, the pattern becomes clear. Writing preserved knowledge. Printing multiplied it. Science expanded it. Coal-powered industry. Oil connected the world. Electricity transformed civilization. Computers accelerated information. The internet connected humanity. Artificial intelligence is now amplifying human intelligence itself. Every leap in knowledge has demanded an even greater leap in energy. The next chapter of civilization will not be defined by technology alone. It will be defined by our ability to build an energy system capable of powering everything that comes next. Thank you for watching. Discover the hidden systems behind energy, engineering, and the technologies shaping our future with H2 Hub by ReneEnergy.